Sentinel North is a research program at Université Laval funded by the Canada First Research Excellence Fund to examine the multidisciplinary approach to climate change and quality of life in the far north, especially in the far north of Canada and Quebec. Within that Sentinel North program, there is a thematic Project 1, which examines complex systems, in particular the structure, function, and interrelationships in the north. And within that thematic Project 1, I am involved in the sub-project 1.5 called Pitutsimaniq, which is a network sensors for real-time surveillance of infrastructure and Nordic ecosystems. Let me start by introducing you to the researchers within this sub-project. I'll start with myself. I'm Leslie Rush, a professor in the Electrical and Computer Engineering Department, and my co-principal investigator is Michel Allard, who is with the Geography Department. We have three other researchers in this team, co-investigators: Guy Doré from the Civil and Environmental Engineering Department, Sophie La Rochelle, who like myself is in the Electrical and Computer Engineering Department, and Canada Excellence Research Chair Younes Messadek, who is in the Physics, Engineering Physics and Optics Department. We have several collaborators at Laval and also outside of the university. So we can see that there are some different expertise which are being brought together for this multidisciplinary sub-project within the Sentinel North program. The objective of this sub-project is to bring science and technology into the service of the northern communities in northern Quebec. The research will be centered on climate change, the impact of climate change. And of course, climate change is of global importance, and our results will be of interest to the global community. In particular, Northern Quebec, as one of the most northern-lying living communities in the world, will be a sentinel for the planet. It is in working with these communities that we're able to observe firsthand what the impact of these changes are and could be on a living community. Therefore, it's a wonderful environment for us to be able to do research. But of course, it's also an indicator that the communities in these locations are highly vulnerable. So our research is not just to increase knowledge, but also to improve the quality of life for these communities by letting our results be brought to these communities as early as possible. So who are these northern communities that I'm talking about? Let me start with an example of one of the communities where we'll be working beginning this summer to try and implement some of our research and development work. So Saluit is the second northernmost Inuit community in Canada, and it is fairly typical of the communities which exist in northern Quebec. There are about a dozen of these communities which are scattered along the coast. So what these communities have in common is that they are completely isolated from southern Quebec. There are no roads that connect these villages with the cities of southern Quebec. There are no roads which connect even these villages with one another. There are no telephone poles bringing services to these cities, to these villages. There are no electrical pylons bringing electricity. They are completely isolated. So these villages, of course, they are served by seaports and airports. The seaports are open during the summer months, and they allow supplies to be brought into these communities. For example, petroleum products are brought in the summer to be able to generate electricity throughout the years for these communities. So they have their own local electrical distribution system. In terms of telecommunication services, these communities are served by satellite connections. And of course, within each community, there is a distribution network to provide internet and other services to members of this community. So what we're focusing on in this research is to support these communities for the protection of the infrastructure. So here we have the city of Saluit, and when I talk about Nordic Infrastructures, I'm talking about the homes, buildings, roads, runways, which are at risk due to climate change. So for instance, the permafrost on which the infrastructure is built is undergoing significant change due to global warming. By examining changes in the permafrost, we hope to understand what kind of damage could be experienced by these infrastructures, and to come up with new practices that will allow these communities to grow, adapt, and provide more enduring structures in the face of this climate change. So we can see that we have the intersection of geography, the understanding of the permafrost, and civil engineering, the understanding of building practices on this environment. And of course, all of this is based on using different sensor technologies, which is where the electrical engineering and physics side comes in. So one of our first objectives is to develop and optimize a wireless network for various sensors in the environmental monitoring. So for instance, we'll be using the LTE wireless service, which is available within the community with backhaul via satellite, in order to come up with a means of real-time monitoring of the environment. Today, there's a large number of sensors deployed in Saluit. However, these sensors are only accessible during a very small part of the year. So although they record data throughout the year, researchers really only have access to this data perhaps once or twice a year, which means that they are not appropriate for any type of early warning system, and therefore we're making this project able to support that capability. One of our second objectives is to develop these detection strategies to look for the heat sources that can predict soil movement and predict infrastructure damage. So we'll also be looking at how to first capture and have available real-time data, and then how to treat that data in order to create an early warning system. Finally, we'll also be developing new novel fiber sensors, which allow for low power operation, to monitor the linear infrastructures. And what I mean by linear infrastructures are long roads, long runways, where a fiber would be a real advantage and provides distributed sensing. So that gives you an idea of how within a community we'll be using science and technology to monitor these infrastructures and develop ways of protecting this infrastructure. So if we were going to look at what the expected impact of our research is, it would be first to enhance the monitoring of these ecosystems and the infrastructures with a new generation of sensors, for instance, for the runway that we see here for Saluit. A second objective would be to provide these communities with the means to protect their homes and their livelihood. So we would have this deployed sensor networks, which provides continuous connectivity. We'll be deploying new multi-core fiber, which will give us an advanced distributed sensing capability. And we'll be monitoring the infrastructures and coming up with new means, new durable solutions to improve the quality of life for these communities. So we'll be focusing first on Saluit, but we're also, more long-term, trying to provide a global view to the Northern Quebec communities and to the regional government so we can help them adapt to climate change and to manage their growth. And if you're curious about the name of our project, Pitutsimaniq, that is our closest approximation to the word network in the Inuktitut language. Thank you.